Hello, hello. Hi there, guys. Am I audible to all of you? Hello. Am I audible? Please let me know if I'm audible. Yeah. So just let me know if I am audible on YouTube live. I would just like to see that. Yeah. Hello. Hello, guys. Can you hear me? Yeah. Current bitrate is higher than what we recommend. We recommend you use a stream bitrate of. Okay. I see some message from them. I don't know. Yeah. Hi. I just write something in the chat box. Hi. Let me know. Let me know if I am audible. Okay. And if there is background sound a lot, I am sorry for that. I cannot control them because there are kids playing outside my house. Like the kids of my area. They are playing there, and they have, you know, as they are full with their tummy, and they are out to play, so they are enjoying out there. Yeah, they have all games, and no, all the kids zone is going on there. So yeah, let us start with the session of the day. Thank you for letting me know I'm audible. Is there any disturbance in the sound from my end? Is my voice clear? Just could you let me know if my voice is clear, or is there any break in the voice, or it's going difficult? Yeah. So now let us begin with the main content that we have to. Yeah. Okay, thank you so much. So I'll begin with the main content. Yeah, this was these were the two questions that I had given last time for practice. Those of you who have done, it's great for them. Those who couldn't manage, it's okay, not a big issue. Let's do it today. Let's see their answers and get it done. These both of them are very simple questions. Only thing is that you need to know the trick. So let us do the first question. So here the question has I equal to z square plus 1 over z into 2z minus 1 over c dz, where c is mod z equals to 1. Now this question we are supposed to use Cauchy residue theorem to solve this, okay, as we have learned so far only that as the formula. Okay, so let us see how to handle this using solve using Cauchy residue theorem. Okay, now the first thing that we had seen in this question was that yeah, thank you for letting me know I'm audible. Yeah, so we'll proceed ahead with this discussion, and we will complete it up today. The session for today is only for 1 hour. We are not going to extend it too much because the main topic of Cauchy residue theorem is related to the formula that we have seen. Apart from this, there are quite a few difficult questions which are generally tackled in a more or less competitive examination, but for the point of view of the main examinations of universities, these kind of the extreme difficult questions aren't taken into account. So we won't be touching those kind of, but we would see a glimpse of them. So I'll just do a bit of setting from my cell phone, and then I can forward some few text. So let us see how uh, the thing happened. Okay, so we are using Cauchy residue theorem now, and let us see how does it work. So first step over here, you have to make the denominator equals to 0, and you have to know where the points the function becomes not defined. So let z into 2z minus 1 equals to 0. So z is equals to 0, or 2z minus 1 is equals to 0. Therefore we get z equals to 0, or z is equals to half. Okay, we let these points as z1 and z2. Yeah, thank you, thank you. Then let me know that I'm audible. So we let these 2 points as z1 and z2 equals to half, and now we are going to go for checking which of these 2 points are inside the circle. Okay, both of them are inside the circle, so we can easily make out here. So these are the points. So z1 is a simple pole, and z2 is also a simple pole. I believe this is semester 4 complex analysis for, so most of the students across the country, it is in semester 4. This is semester 4. Okay, uh, so this is simple pole. Now what do? We are going to check which of them are inside the circle, and it is very obvious looking at this. Z1 is 0, mod, if you do, that is 0, which is less than the radius, and we can also say z2, which is mod of half, which is half, that is also less than the radius. Hence hence z1 and z2 lie inside the circle, mhm, circle C. Okay, lie inside the circle C. This is step number 2, that you had to check whether the points that we got are inside the circle or not. Now we are going to calculate the residue at this. At this step also you can do one thing. I had told you, you can define your function. So here the function is, here f of z is equals to z square plus 1 over z into 2z minus 1 is the function. Now step number 3 is going to be that we calculate the residue. Step 3 is calculation of the residue. So residue over here is residue of f of z at z equals to z1. Okay, and since the pole are simple pole, so the formula is limit z tending to z1 z minus z1 times f of z. Now if you are a bit smart, okay, I will tell you a shortcut also at this stage. First let us do this thing, and I'm sure you are very smart. Okay, I'm very sure that you are smart, and you are above that, but let me give you a shortcut technique. Limit and all this is all technical mathematics, but let me tell you a shortcut technique also. What is residue at the end of the day? So here when you substitute limit z tending to 0 z minus 0 into f of z, f of z is z square plus 1 z into 2z minus 1, right? That's the question. And yeah, so when you solve this gets cancelled. So limit z tending to 0 for z square plus 1 to z minus 1. Okay, so the moment you substitute this, you get over here 0 square plus 1 over 0 minus 1, that is minus 1 is the answer you get. Now see, in short, what you can do if you are doing any competitive examination, what is going to happen here. If you are in a competitive examination, you can directly calculate what is residue. Once you find the points which are there inside the circle, residue is nothing but you delete that point which is inside the circle. From the denominator you delete that point. Whatever is remaining, you evaluate your function at that. Okay, so delete that part which is inside the circle from the denominator of the function, and evaluate the remaining chunk at that point. ये शॉर्टकट है. बेसिकली करना वही है. z सर्कल के अंदर आ रहा था z माइनस जेड नॉट, तो z को डिलीट कर दो और z कौन से पॉइंट पे आया, 0 पे इवेल्युएट कर दो, फटाफट आंसर आता है. ये थोड़ा माइंड को ट्रेन करने का बात है और कुछ नहीं. ओके, ये ट्रेनिंग दे दिया तो हो जाएगा आपका काम. चलिए, तो अब यहाँ से वी कैलकुलेट द नेक्स्ट पार्ट, the residue. So this is one residue we have got, which is minus 1, and other residue is, now let's do by that shortcut, but we will write down the formula also, z equals to z2. So limit, we have to delete the other part, right? So now be careful, see what happens. Z minus z2, z minus z2 into f of z, z tending to z2. So here it is limit z tending to, the second point that we have found is half. Okay, so here it is z minus half, and here the function is z square plus 1 over z into 2z minus 1, right? Simplify this, what do you get? Here you get 2z minus 1 divided by 2 and z square plus 1 over z into 2z minus 1. 2z minus 1, 2z minus 1 gets cancelled. Limit z tending to half. So you have to be little careful. Your denominator should be always of the form of z minus z naught. So here in this case it was not. So that shortcut technique works when your denominator is of the form z minus z naught. If it is of az minus some b, then you will have to pull a outside and make it z b minus a. All these shortcuts now, they have all loopholes. You have to be very careful. So remember all this. Yeah, substitute here. So what do we get is half square plus 1 divided by 2 into half, right? So here you will get 1 by 4 plus 1, that is going to be 5 by 4. Okay, so 5 by 4 is the answer. Good evening. Yeah, we have one comment or a query. So the topic is from semester 4. It is the topic complex analysis, rather complex integration is the topic. Integration, or you can have in your syllabus, I don't know what is your university or anything, but complex analysis could be the topic. Complex integration. ओ जल्दी अगर उनसे कोई ये मिलता है तो हम बात बढ़ाएंगे आगे. अभी तो I am catering in purely in mathematical background. So if we have all those kind of mergers and everything happening, I would be very happy for that. Okay, so we have this here, and so 5 by 4 is there, and now we go for the final step. So final step is step number 4. We go for what do we call, and oh, so now here step number 4 is going to be what do we call is Cauchy residue theorem. So I is equal to 2 pi I total of the residue. So residue of f of z, z equals to z1 plus residue of f of z, z equals to z2. Okay, be very careful while writing z and all, so that will help you. So 2 pi I, we had got an answer for one answer was -1, the other answer is 5 by 4. Total it up, we get 2 pi I, and then here from this you get 1 by 4, so final answer is pi I by 2. This is one of the answer that you would have got. Okay. Please hit like if you have got the gist of this answer or you have followed this. You need to write here in the beginning that it is by Cauchy residue theorem. Okay, by Cauchy residue theorem. This is how the answer comes. Great. Please hit like, let me know if you have any difficulty. This was one of the question that I had taken I had given you in this previous live session, so I thought that I would solve that and people would benefit out of it. Now we take up one more question which was there in the previous live session. Yeah, th this question is also a good one. So let us take that. So I equal to integral 1 minus e raised to z square over z cube dz c. Okay, this is a question that was there in the last one of the examples, and this example had curve curve in this question is c is mod z minus 2 equal to 1. This is a very good question, so let us do this, and it's very straightforward. Answer is, see, let z cube equals to 0. Okay, let z cube equals to 0, so z is equals to 0 0 0, right, 3 times. So here you can say z1 is equals to 0 is a pole of order 3. Now to check whether it is lying inside the circle or not, so you just have to put z1 minus 2. You check z1 minus 2 mod. When you check, it is 0 minus 2, and this is minus of 2 ka mod, so this is going to give you 2, and 2 is greater than 1, which is the radius. Therefore you conclude that z1 lies outside the circle, right, outside circle, and hence you don't have residue. You don't have residue at this point, so answer is going to be 0. So I answer is 0. Straightforward, nothing else. No Cauchy residue theorem. Cauchy residue theorem strictly says all those points, the answer is inside the circle, the answer is there. Residue outside, it's going to be 0, so answer is 0. Okay, have you followed this? Just hit thumbs up if you come to know. What is the formula for the Cauchy residue theorem? Hello, yeah. Yeah, sure, we would do that. We would do that. Offline classes also, yeah, thank you. I would be very much interested for that too. Yeah, we would do that. Sure. So, what is the formula for Cauchy residue theorem? Let me give you the hint again. लास्ट लाइव लेक्चर यही कराया था बेटा, तो आज आपके लिए वापस एक बार एक झलक दिखा देते हैं कॉची रेसिड्यू फॉर्मूला क्या है, कॉची रेसिड्यू थ्योरम। ये रहा कॉची रेसिड्यू थ्योरम, तो ये झलक आपके लिए है, तो एक बार देख लीजिए कॉची रेसिड्यू थ्योरम क्या है और फिर लिख लीजिए। पहले हो सकेगा तो टेक अ स्क्रीनशॉट, देन दैट वुड बी वेरी गुड फॉर अस। प्लीज हिट like and yeah, so I can take up the whole thing. So we are here, ये कॉची रेसिड्यू थियरम है, ये स्टेटमेंट है, ओके। और रेसिड्यू कैसे कैलकुलेट करते हैं, ये रहा सिंपल पोल का फॉर्मूला। और ये रहा पोल ऑफ ऑर्डर एम का फॉर्मूला, ठीक है। तो ये देख लिया है अगर आपने, तो आप इसका स्क्रीनशॉट ले लीजिए। टेक अ स्क्रीनशॉट ऑफ द सेम, it will help you to, you know, go further and quickly. So yes, it is from M4. For those of you are in Mumbai University, you, this is a topic from Maths 4. It is there for every branch, I believe. Yeah, okay. So thank yeah, now let us take up quickly a question which is very popular and always there in most of the examination. Either it is there in the regular examination, one or the other branch gets this question every now and then. Let me take up the most important and the most popular ones so that you know and you will benefit out of that, okay. So these are some popular questions which are there in every class, uh, and I is equal to integration cos pi z square plus sin pi z square divided by z minus z square c dz, where, good evening, good evening. Yeah, so just let me know if you are following all this, and if you have any difficulty you can put it in comment section. कमेंट में डालिए फटाफट, तो थोड़ा हमको भी पता चले कि आपको समझ में आ रहा है कि नहीं। वेयर सी इज mod z minus 2 इज इक्वल्स टू 4। अभी देखिए ये वाले क्वेश्चन में सर्कल थोड़ा सा हटके है, तो हम ये क्वेश्चन ज़रूर करते हैं, ओके। लेट अस डू दिस क्वेश्चन नाउ। Very crucial and very important question, asked many times in examinations of various different universities or even in MU also, okay. Some or the other examination they ask this one or the other one. There are 2-3 similar and popular kind of questions are there, they keep asking now and then. We would see them too, okay. So see this, how to handle this again. No, not a big issue, same procedure. Let, so step number 1, you, in this you do let z minus z square equals to 0. Oh yeah, thank you, thank you. Yeah, thank you, thank you. Yeah, you can contact me on my email ID, or you can drop me an email over here. I would contact you, okay. Yeah, you can let me know, I will surely contact you back. So z minus z square is equals to 0. लास्ट लेक्चर का सेकंड का प्रैक्टिस क्वेश्चन अभी बताया, थोड़ी देर पहले ही मैंने बताया, 0 आंसर है उसका। ये देखो ये रहा आंसर 0, आउटसाइड द सर्कल आता है इसलिए आंसर 0। अभी हम आगे वाला प्रॉब्लम कर रहे हैं. नाउ वील फोकस अपॉन दिस क्वेश्चन. लेट z minus z square equals to 0. You let this thing happen 0. Therefore z, when you take it out, so it is 1 minus z is equals to 0. So z is equals to 0. Now, or 1 minus z is equals to 0. So z equals to 0, or z is equals to 1. So you write z1 and z2 equals to 1. So we are now supposed to check who are inside the circle. So step number 2. Step number 2 is, your circle is mod z minus 2 is equals to 4. Therefore, what do we get here? Z1 minus 2, when you want to check, we have to now check whether mod of z1 minus 2 is less than 4. This is what we have to check. Okay, so first let us complete this question, then if we have any doubt regarding that second question, I will explain it that. Okay, so right now we will focus upon this one. So z1 minus 2, when you want to do, so you get 0 minus 2 is mod of minus 2. Mod of minus 2 is 2. Now this mod of minus 2 has become 2, so this quantity is less than 4, right? That means z1 lies inside C. Okay. Okay, now we go for the next part. Here we have to check z2 minus 2. When we want to check z2 minus 2, here you can write also z2 minus 2. So what about that? Z2 1, it is 1 minus 2, right? This has become 4, right? So it has to be less than 4. So let us see what do we get. Minus 1 is less than 4. Yeah, mod of minus 1 is 1, right? So mod of minus 1, which is 1, that is less than 4. Therefore, what do we do now? So we write z2 lies inside C. 2 points are inside C. Again, story goes the same. So at this stage you can define the function also. So the function is f of z is equals to cos pi z square plus sine pi z square divided by, now see the denominator which is there, instead of writing z minus z square, it would be a good advice if you factorize and write it. Okay, just write like this, it would be a good thing, 1 minus z, right? This helps you better. That is why I wanted to write the function separately. This gives a better insight how you are proceeding. Now let us calculate the residue. So while calculating residue, step number 3 comes into the picture. Step number 3 is residue. So when we calculate the residue of f of z at z equals to z1, we are going to use the formula limit z tending to z1, z minus z1 times f of z. So substitute here limit z tending to z1. Our z1 is 0. Okay. So z minus 0 times cos pi z square plus sine pi z square divided by z into 1 minus z. Now you can clearly see that this is going to get cancelled. Right, now you substitute the value for z equals to 0, so what you get is cos 0 plus sine 0 over 1. So cos 0 plus sine 0 is 1. 1 over 1, answer is 1. So first residue is 1. This is again a very simple thing. Okay, I hope you got this. Please let me know in the section that you are able to follow this, in the comment section, that you are able to follow. Yeah, there are many people I know whose name is Vedant. Okay, many I know. I In my teaching career I have known around 35 to 45 people whose name is Vedant. I don't now know which one are you talking about. Everybody knows, there are so many people with that name. Yeah, thank you for following this part. We followed how to calculate the residue. So now we calculate the second one. Second one is slightly important and a different one. So I'll write it in a blue part, or let's write with a white one. So residue of f of z at z equals to z2. What is the formula again? Since it is a simple pole, so I think we have not mentioned anywhere whether it is a simple pole or a multiple pole, pole of order m. So you just understand that z1 and z2 are simple. Okay, they are simple pole here. So when you are writing here z tending to z2, z minus z2, and then there is the formula f of z. So this limit z is tending to 1 in this case, right? Z minus 1 we have. See this. Now you have to be very careful in this example. Here in numerator there is cos pi z square, that is okay, plus sin pi z square, that is also okay, but in denominator there is z into 1 minus z. So the moment when we do the cancellation, you will be left with minus 1 over here. So the limit will become negative. So minus, if you are doing the cancellation, here you will be left with minus 1, right? So be very careful about this part. Okay, so here you have minus 1 coming into the picture when you cancel. So cos, what you will be left is cos pi z square plus sin pi z square over z. Many children make mistake and they write 1 at this time in the प्रोसेस ऑफ गोइंग इन द शॉर्टकट कि फटाफट आंसर आ जाएगा और क्या फ़र्क पड़ता है, आंसर लाने का है। आंसर लाने का नहीं भाई, ये इसमें छोटा छोटा माइनस प्लस में ही सब गड़बड़ होके मार्क्स नहीं मिलता है। यू हैव टू बी वेरी केयरफुल एट दिस स्टेज. दिस इज एन इम्पॉर्टेंट स्टेप अकॉर्डिंग टू मी वेयर चिल्ड्रन मेक मिस्टेक. Now, what do we do over here is we substitute z equals to 1. So, minus limit z tending to 1. So, cos pi plus sin, now when we are, when we are substituting over here the limit, so we will just write the final part. So minus sign remain outside, so cos pi plus sin pi over 1. So sin pi value is 0, cos pi value is minus of 1. Okay, So here it is, minus sign is already there, so it is minus 1 plus 0 over 1, answer is 1. So residue in this case is also 1. So my final answer, therefore step number 4 will be by Cauchy residue theorem. We have I equal to 2 pi I times the total of the two residues, whatever number of residues we got, residue of f of z at z equals to 1, right, z equals to z1 and z2, so 1 and 0, right. So these are the values, so at 0 and residue of f of z at z equal to 1. So, and please remember, make a difference between z and 2. Okay. Okay, so now we go about this. So 2 pi I, and then there is 1 plus 1 over here. So this is 4 pi I is the answer in this case. So this kind of answer we got in the last live also for this kind of questions. So now one more important question, let me take up this. It is again a important one. It is very popular amongst the examinations, so I'll do it over here. I is equal to integral sine raised to 6z divided by z minus pi by 6 whole raised to 3 dz c, where c is mod z equal to 1. Now in this case what is going to happen is we are going to have a multiple pole. So let us write down that. So let z minus pi by 6 whole raised to 3 equals to 0. Therefore z is equals to pi by 6, pi by 6, pi by 6. Okay. Now what are we going to get over here? We are going to get here z1 as a pole of order 3. Okay, so here z1 equal to pi by 6 is a pole of order 3, is a pole of order 3, hence we have one value for m we can write here, so this m value is 3. Now we also check that whether this pole is inside the circle or not. So pi by 6 is always inside the circle. So you, if you want to note down the value, it is, see, pi is value as a decimal value, if you take it is 3.14 and so on. If you divide it by 6, it is obviously less than 1, hence it is going to be less than 1. That means it is going to lie inside the circle. Okay. So now what do we do here? We will check whether the number pi by 6 lies inside the circle or not. So here c is mod z equal to 1, therefore z1 equal to pi by 6, so pi by 6 ka mod is less than 1, therefore z1 lies inside C. Now we have to find residue. So residue of f of z at z equals to z1 is going to be 1 upon m minus 1 factorial limit z tending to z1 d by dz power m minus 1 m minus 1 into z minus z1 to the power m f of z. Okay, so now what we will do over here, m is equals to 3, so 3 minus 1 is 2 factorial, 3 minus 1. I'll write all the steps so that those of you are writing step by step, you get to know what all things are there. Here we will go limit tending to pi by 6, double derivative we will have to take, okay, of what function, z minus pi by 6 whole raised to 3 times f of z. Now the f of z is going to be the function. See, here we did not declare the function. You can declare the function. Here your f of z is going to be sine raised to 6z over z minus pi by 6 whole raised to 3. Okay. Okay. So now what do we do over here? That sine raised to 6 sine raised to 6 of z over z minus pi by 6 the whole cube, this is the function. So you substitute the value sine raised to 6 z over z minus pi by 6 whole raised to 3. Now you can cancel here this part. Now when you are doing the derivative, be very careful. This is the place where derivative is very important. This helps you to be little bit cautious and don't jump the steps in this case. So we substitute here. So 1 by 2 limit z tending to pi by 6 double derivative d z square of sine raised to 6 z. Now how we do the derivative of this, you have to be careful. Be little careful while doing the derivative. So you first do the first derivative of sine raised to 6z. So the first derivative over here is going to be 1 by 2 limit z pi by 6. When you do d by dz, now this is 6 into sine raised to phi z into cos z. Okay. So after this we will do the UV rule. Okay. While doing the UV rule, be little careful, otherwise there are chances of that going wrong. So now while doing UV rule, it will be 1 by 2 limit z tending to pi by 6. In UV rule, what will happen? 6 is constant, so 6 will come outside. So I'll write it over here. So 6 divided by 2, I'll keep it. Now there is next part is sine raised to phi z into cos z. So sine raised to phi z, derivative of cos z we have to write, that is minus of sine z, then plus cos z into phi times sine raised to 4z into cos z again. Okay, this is the chain rule that you will have to apply and do it carefully. So 3 times limit z tending to pi by 6, and here we have minus of sine to the power 6z plus phi into cos square z sine raised to 4z. Okay, this is what you get. Okay, now you start substituting the value for pi by 6 in place of z. So you get 3 is outside, minus sine raised to 6 pi by 6 plus phi cos square pi by 6 into sine raised to 4 pi by 6. Okay, so 3 times this sine raised to 6 pi by 6. Now pi by 6 is 180 divided by 6 is going to give you 30. 30 sine 30 is half. Okay, so this is half raised to 6. Then over here you have that is what you will get, and then here it is 5 times cos square. Now cos of 30 degree is same as sine 60. Sine 60 is root 3 by 2. So here it is root 3 by 2 the whole square into, here it is half raised to 4. Okay, when you simplify this in your calculator, you will get your answer somewhere around this full chunk. If you simplify, you will get 21 by 32. Just check your answer and let me know whether you get that. Let me know, do you get this answer? all those who are there, are you getting this answer? 21 by 32 must be the answer that you must be getting. I hope you get this answer. So just continue. I'll continue with this. I see people are busy in calculation. So by the time you land up on the same answer, you verify your calculations, and final answer over here we will be writing down that by Cauchy residue theorem. You have I value is 2 pi I times 21 by 32, and that gives you pi I times 21 by 16. Okay, that's my final answer. So this is what we are going to go about, and that's what this section is basically dealing with. Now there are one or two difficult questions. I don't say them difficult, but non-trivial answers. Okay, like this question you can try, or I would like you to do this kind of one, which is nice, elegantly difficult, you can call them. Okay, you can get anything. There is no restriction on Cauchy residue theorem whether what kind of question they should ask or they should not ask. All the kind of questions are allowed. It depends entirely upon the examiner and the paper setter who wants what kind of questions to put in it. Questions are all there out. You have to solve them carefully. That's it. Okay. So there are several questions. So let me try give you this kind of one for your practice. You can practice this. That let's say you this is a very non-trivial question. So e raised to z into z square plus 4 over z minus I the whole cube c. Okay, dz, where mod z is equals to 2. So the answer for this question comes like somewhere around 4 plus phi I times pi into e to the power I. This is the answer for this question. So if you do this, you will get to this answer. It's a very non-trivial answer. Okay, this is a very non-trivial answer. So do try this and you will get to know. And after this there is one more non-trivial question. I'll give you that too, so that you know the difficulty level settles in your mind, that what all kind of questions can come. Z times cos h pi z divided by z raised to 4 plus phi z square plus 4 dz. Okay, and mod z is equals to 4. See, you have to use your answer in this case will be minus of 4 pi I by 3. This is the answer. There are several questions on this that you can try. Okay. Do you wish me to do any other kind of question on this, so that you have any difficulty that can be solved in this? I'll give you a hint for the last question that I have given you to try on your own. So the question here, the hint I'll give you, the hint is, firstly, when you put z raised to 4 plus 5 z square plus 4 equal to 0, if it is a biquadratic equation, okay, it is a biquadratic equation, and to solve this question you will need either a help of a calculator to calculate this, or you can easily put here, put z square equal to m. So therefore what you get is m square plus 5m plus 4 equals to 0. So m plus 4, m plus 1 are the factors at the initial stage. So m equals to minus 4 or m is equals to minus 1. So the moment you put m again as z square, so z square is minus 4 or z square is minus 1. Hence when you simplify further, you will get the value for z as plus minus 2i, and here you will get z equals to plus minus I. So z equals to z1 is equal to 2i, z2 equal to minus 2i, and z3 equal to I, and z4 equal to minus I. These are the 4 points that you will get over here. Now you have to check which of the 4 are inside the circle. Fortunately all 4 are inside the circle, so you will have to calculate residue at each of the 4 points, okay, and you will get your answer. So this is how this sum will work. So because z1 mod, if you take, it is mod of 2i, so that is 2 which is less than 4. z2 mod is also minus 2i, which is 2 which is less than 4. z3 is going to be I mod, and that is 1 which is less than 4. z4 mod is also 1 which is less than 4. So all of them are inside the circle. So now when you go to calculate the residue, remember your function, in this case when you write your function, you must write it very nicely. Your function f of z is z into cos h. Here it is cos h pi z divided by, now instead of writing the entire biquadratic equation there, biquadratic polynomial, you write here, I would suggest that you write z minus 2i, z plus 2i, z minus I, z plus I. This is the 4. Now see, in exams they have not asked so far the questions where 4 what you call residues come in the denominator, or like 4 poles are there. They generally ask maximum up to 2 poles or 3 poles, okay. These are the kind of questions are asked in the examination, but it is not binding upon them to not to ask these kind of questions. They can ask you 4 poles questions which are there, so this is also doable question, it's not that difficult. So you calculate residue at each of the terms. So I'll just help you out with residue of f of z at z equal to z1 will be, you write that limit is z tending to 2I, so it will be 2I into I'll not write directly. Let me write directly because I showed you that shortcut technique, right? So you have to delete that point where that residue is there. So it is 2I into cos h 2 pi I divided by, so here it is 4I, and then 2I minus I is I, and 2I plus I is 3I. Okay, so you have one I getting cancelled, and then it is, here it is 4 into this 2, so here it is cos h 2 pi I divided by 6I square, that is going to be minus of cos h 2 pi I divided by 6. That's what you will get. Now when you have the other version, you calculate res of f of z, z equal to z2, so that is minus 2 pi I cos h minus 2 pi I divided by, now when it is minus 2, this will get cancelled and you have 4I minus 3I and minus I coming over here. Okay, that is how the whole thing will work. So you calculate all this and you get your answers. So these answers you calculate, and minus I and I, this gets cancelled, 2 gets cancelled with this, so here you will have I, so cos h minus 2 pi I, and here it is minus and minus makes it plus, so 6I square again, and then there is minus cos h. Now cos h of minus theta is cos h theta, remember this, okay? Cos h minus of x is cos h of x. There's no change here, so 2 pi I divided by 6. That's what you will get. And then similarly you calculate for residue for f of z at z equals to z3. z3 is I, so it is I times cos h pi I divided by, so I minus, here I minus 2I is going to be minus I, here it is 3I, here it is I minus I is 0, so you will neglect that, I plus I is 2I. Sorry. So minus of, yeah, so minus will get cancelled, and finally again you get your cos h pi I over 6. That is what you would get. And similarly, can you calculate the residue for f of z at z equals to 4? I think it would be minus I coming there, right? Minus I times cos h minus pi I divided by, with minus I, that this gets cancelled, minus 2I. Okay, and then there is minus I, so minus 3I, and then there is I. That minus minus gets cancelled. Okay, so here you have cos h pi I, 2 into 3 is 6, I square is minus 1, minus and minus makes it plus, so I think there is some I getting cancelled, yeah, I is also getting cancelled, so again here this is 6. So you handle this accordingly, and your 4 residues are available with you, you substitute them, you get your answer. Okay, I think I have done half of the part for this. Okay, so I hope all the questions that I have solved so far and uh, given you the whole different setup for finding different this Cauchy residue theorem questions, you can have a good understanding about it. You can also try this simple question on this if you want. It's a very easy question. Again, the answer for this I'll give you. I'll not solve for the residue or nor give you the hint because I have already shown you when the quadratic equation is there in the denominator, how do you tackle. So this, we already had a biquadratic, now this is just a quadratic equation here. So you can try this equals to 2. The answer for this will be 380, sorry, 38 pi I by 3. That's the answer. You can try this. You can even try a very simpler version of the same 2z over z square pi square dz. Answer is for this, oh, c, here c is, here for you the c is mod z equal to 4, and for this question the answer is 4 pi I. Very simple. You can try these few questions for yourself. Okay, I hope you don't have any doubt on your end. If you have any doubt, please let me know in the comment section. I would be happy to guide you any doubt on Cauchy residue theorem. I am done for the topic on Cauchy residue theorem. I will soon see you on Cauchy integral formula and its versions. Yeah. Let me know your doubt. I'll be waiting. Thank you for joining in, and this is all on my side. It's it's really commendable for you all that you are having extremely busy day throughout. You people are working in your colleges with your submissions and assignments and projects and everything, and at the end of the day you still make up to the lectures online. It's really commendable. So thank you for joining in over here, and do let me know if you have any doubt. I'll note down your suggestion that I would like to teach in Hindi. I appreciate your suggestion, but I don't know what do you call, uh, all these terms in Hindi. I don't know what residue and integration, everything would be called in Hindi. So I refrain myself from using that. आई नो व्हाट डू यू मीन, बट अगर हिंदी में सिखाना ही है तो पूर्णतया हिंदी में सिखाया जाए. आधा हिंदी आधा अंग्रेजी में सिखाओगे तो सब गड़बड़ होके सब खिचड़ी हो जाएगा. मैं जानता हूँ आप क्या कह रहे हैं, पर मुझे आई प्रिफर वन side, because there are people who are overseas and they may not be conversant with Hindi. So I avoid uh, taking it right now. Maybe in future I'll make up the mix of Hindi English, both mix. I'll note down that suggestion. Thank you. Yeah. So any doubts on your end? If no, there are no doubts, then we can wind up and close the session. If there are any doubts, let me know. Otherwise, I'll wind up the session. If there are any comments that I have missed. Yeah, I'm audible. Good evening. Please explain step 2 again. Yeah. What step 2 you needed? I would like to know that step 2 regarding what step. Yeah, I don't know. Yeah, thank you. Yeah. Yeah. Okay, thank you. Thank you for joining in. S- Thank you for your feedback and comments and every uh, support that you have shown so far. I'll stop the video for the day. Thank you. We will soon meet in the next session on Cauchy integral formula. Thank you.